Okay, so when you multiply, root 3 times root 6 is the root of 3 times 6, which is root 18. But because 6 has a factor of 3, we then have 18 is 9 times 2, which is 3 root 2. Root 60, because 6 has a factor of 2 and so does 10, we have two factors of 2 multiplied together. 2 squared is 4, and we end up with 2 root 15. And we have 15 fence rails, each of which is 2 root 5 feet long. 15 times 2 root 5 is 30 root 5. That's an exact value. A rectangle has a width of 4x, a length of 4x and a width of 5y. Determine the area of the rectangle in terms of x and y. What would be a good first step? Draw a rectangle and label it, right? It's always good to see, what are we dealing with here? So we got a length of 4x, got a width of 5y. What's area? What's a formula for area of a rectangle? Length times width. The length is 4x, width is 5y. The answer is 20 what? XY.
I know.
So determine the area. Determine means show your work. So we've shown some work, right? I wrote down a formula. I substituted in the formula. I've drawn a diagram so we can see, hey, here's the length, here's the width. And we have the area in terms of xy. It's 20 times xy. Okay, questions? You've done that in junior high, right? If the value of x is root 6 and the value of y is root 2, then the length of the rectangle is, okay, what was the length? 4x. But x is root 6, so what's the length? For root 6. And what's the width? 5 root 2. Determine the area of the rectangle and write that answer as an exact value. Verify your answer with the calculator. Okay, so area is length times width, which is 4 root 6 times 5 root 2. Okay, what do we get? 20 root 12. Right. So we multiply 4 times 5. You multiply the coefficients, the numbers together, you get 20. Multiply the numbers under the radical, you get 20 root 12. But what's root 12? So actually what I want to see is that root 12 is 2 root 3. You can take as long as you want to get there, right? You show as many steps or as few steps. So if we know that 12 is 2 root 3, that's great. We could go over here and go root 12 is the root of 4 times 3, which is root 4 root 3, which is 2 root 3. Okay, so you can show that work. If you don't need to, you can do it. So I'd kind of do it over here, but you can do it in line. Doesn't matter, right? And what's this equal to? 40 root 3. Okay, now you want to check and see if that's the same, right? So what do we got? We got the other page, we had 20xy, right? 20 times root 6. Now I need to arrow out of the radical, right? So it's 20 times root 6 times root 2. Times root 2. Enter. And we have 40 times root 3. So when I hit enter, what should I see? 0.28203. So have we verified? Yes. Right? So we have an expression, an algebraic expression from the previous page. Length is x and width is y. Remember, we have 20xy. And we have this expression, they're the same, right? So 40 root 3. It's all good. This is a mixed radical in simplest form. There's no squares that go into 3, right? So just always look under here. If it's an 8, So, could have gone further, right? 8 is 2. If there's a 12 under there, if there's a, anything that's divisible by 4, 9, 16, 25, 36, and so on. Okay, questions? In general, to be revealed. If A root B is multiplied by C root D, then what's the product? A times C, the root of B times D. Remember, the product may have to be simplified. I don't know why the reveal is here, because you're sitting looking at the sheet, right? So it's sort of like, okay. Simplify the following. Okay, what do we get? What am I going to write first? 20 root 18. And root 18 is? Yeah, so 9 times 2, 3 root 2. Okay. I don't need to see how you got root 18 to 3 root 2. Just you get 18 to be 3 root 2, and the final answer is 60 root 2. So if you're handing this test in early, what are you saying to me? You're saying I've checked everything, right? Like anything with radicals, I have verified, and I've made sure that, 20 root 18 might be given as an answer, but say the answer expressed in simplest form is, and it's this, right? Yeah, that's an answer, but that's just to catch the people who aren't reading the question, right? It's got to be expressed in simplest form, which is 60 root 2. Okay, what do we get here? So I might want to do this. I might just say, there's too much there, right? I need to break it out. So it's negative 3 times 7 times 4, which is negative 84. Root? 60. Okay, now we know root 60 is 2 root 15. And so we end up with negative 168 root 15. Okay? I'll give you a chance to copy that down. So multiplication, actually pretty easy, right? The only thing I remember at the end is now I got to look and see what's under the radical sign. I got to change that to a simplified mixed radical, and then simplify the expression. How do you check this? You go negative 3 root 5 times 7 root 2 times 4 root 6. Just be careful on your calculator. Make sure you move out from under the root sign before you type this. And then you type this and you say, hey, they're the same. Simplify the following. So we have a monomial times a binomial, right? That means that the number in front, the expression in front, multiplies. Okay, what's 2 root 6 times 5 root 2? 10 root 12. What do we get here? Okay. It's okay. You can write that out.
Can you just do 2 root 6?
What's root 12? 2 root 3. What's root 36? 6. So what you can do is this. You say it's 2. Root 6 times root 6 is 6. So it's 2 times 6. So if you just wrote a 12 here, I'd be okay with that. If you wrote 2 times 6 there, I'd be okay with that. If you wrote 2 root 36 there, I'd be okay with that. Okay? Any expression, right? It's okay to write the root 30, just as long as you realize that, oh yeah, that's just going to be a 6. Okay, so what's our final answer? 20 root 3 minus 12. Can't simplify it any further, right? It's not a root 3 and then another root 3, right? Just 20 root 3 minus 12. Okay, what do we do for the next one? So we're squaring a binomial. So I might want to write it out like this, right? Especially with radicals. If that was like x minus 3 squared, I might just do that in my head. But it's not. Okay, what do you want to do for 2 root 3 times 2 root 3? 4 root 9. Then what do we get? Minus 10 root 18. Then what do we get? Minus another 10 root 18. And then what do we get? Plus, okay, minus times a minus. 25 root 36. Okay, root 9 is minus 10 root 18 minus another 10 root 18s is how many root 18s? Minus 20, right? So remember, when I'm adding or subtracting, they're like radicals, right? They're both root 18. So the answer, you don't add the 18s, right? You don't say, hey, I got 18 and 18 is 36. It's like, just say to yourself, if that were an x and that were an x, minus 10x would be minus 20x. But it's not an x, it's a root 18. So I got minus 20 root 18 plus 25 times 6. Okay. So that's 12 minus 20. What's root 18? Okay, 3 root 2. I don't care how you get it. I don't care if you show me how you got it. I do care that it's correct, right? So when you're doing it, right, if you're going root 18 is 3 root 2, go to your calculator right now. Grab your calculator, go root 18, enter. Go 3 root 2, enter. How long does it take? Time yourself. Don't write it down, just go root 18, enter, 3 root 2, enter. Look at your, just say, how long did that take me? So how long did that take you? Not long, right? We're just going not long. Where not long is something less than, what, 10 seconds maybe? Are they the same? Yes. Good. Then, before you go on, right, you know this is right. What if you know, a lot of times you might go root 18 and go 2 root 3, which is actually root 12. So take the 10 seconds and check it out. Root 18 is 3 root 2. How do I know, right? Eventually you're going to know root 18 is 3 root 2. You're not going to have to go and check it. Okay? Until then, take a moment. It's not that long. 25 times 6, 150. So what do we got? 162 minus. Okay, so what am I going to do? I'm going to go bracket 2 root 3. I can just write it beside each other, right? Minus 5 root 6 out of there. Close the bracket and square that, right? Because that's what that is. And I'm going to go 162 minus, what's the other thing? Was it 60 root 2 minus 60. And what's going to happen when I hit enter? Well, I hope so. Okay. Good to know, right? How long did that take? Not long. Let's go with not long. It doesn't take long to check a radical. If it's wrong, leave it, go on, and come back to it later. Okay? I don't want, because if it's wrong, you can sit there and spend 10 minutes trying to fix it. That's not a good use of your time at that moment. It's just enough that you need to flag it, right? Circle it, whatever. Just say, need to come back to this. I know it's wrong. Or you made a mistake in the verifying. You might have typed something in wrong. You don't know for sure. And you don't want to spend 10 minutes correcting. It might even be right. And you just typed in your calculator wrong. Something happened. You didn't exit the root sign, right? So you ended up with 2 root 3 minus 5 root 6, all under one root sign, and you squared it, right? You don't know that. So leave it, go on, come back to it, recheck it, making sure this time, okay? Don't spend, you can spend 10 minutes trying to fix something that's right, and you'll make it wrong, and you'll spend 10 minutes doing that, and then you won't get finished the test, and it'll be like, this test was too long, and it's not, right? So, work smarter, not harder. The root of 24 over 8, oh sorry, the root of 24 over the root of 8 is the root of 24 over 8. What's 24 divided by 8? 3. Or the root of 24. So this could be 4 root 6. I don't even know where we're going here. 2 root 2. Oh, yeah. Good idea. Smart. Good man. It's root 3 times root 8, right? Which we would never really write. But now you can cancel the root 8s. Be left with the 3. Good. Thank you. Okay. Generally, we would not write. We would write it as 4 times 6 and 2 root 6. But that's not what we're trying to do here, right? We're saying, hey, if I can get a root 8 up here, these guys will cancel. I'm left with root 3. I always just do it this way, right? Because 24 divided by 8 is 3. All right, let's reveal as if it's like hidden. Okay, so the root of 200 over the root of 50 is the root of 200 over 50, which is what? So that's root 4, and root 4 is 2. Okay, how can you check that? You could go root 200 divided by root 50, hit enter, you expect to see 2. Or, all right, I know what to do this time. It's 4 times 50, and there's a 50, so we get root 4, which is 2. Okay, so you got a couple of strategies you can use. You need to pick the one that's right for you. What do I care about? I care about if I give you root 200 over root 50, you get an answer of 2. If I ask you to do algebraically, you're showing one of these ways. Okay, or if it says determine, right, you're showing one of these ways. Okay, questions? Good, everybody's ready to move on. The area of a rectangle is 10 root 48. If the length of the rectangle is 5 root 6, determine the width and write you answer. Write you answer as an exact value. Somebody ought to proof this stuff. We only care to deliver the very best. Okay, method 1, what would we do? Well, basically we've done the 2 methods for everything, right? So what do we know about area? Area is length times width. If I wanted to draw this, I could go in here and write this is 10 root 48, and the length L is equal to 5 root 6, and there's W. So now I could fill in, right? Or I could rearrange. What are we trying to solve for? The width. So let's rewrite this. So it says W equals. What's W equal to? A divided by L. Okay, W equals A over L. What's A? 10 root 48. What's L? 5 root 6. Okay, so method 1 says, what do? We put them together under the same radical sign, right? So we've got 2, and then we've got root 48 over 6. Okay, so I'm doing the division. Jeez. I can't even undo that. Okay. So I've got 2 root of 48 over 6, which is 2. What's 48 divided by 6? 8. 2 root 8. What's root 8? 2 root 2. And what's the final answer? 4 root 2. Yep.
Can we just get to
Yep.
2 root 8 instead of 2 square root 48 times 6?
I want to see this.
Okay.
And I want something that justifies it, right? So you can't write this and then write this and then go straight to here. But you could go straight from here. From here, you could go to 2 root 8.
Yeah.
And then from there, you could go to 4 root 2. I don't even need to see the 2 root 2. Okay? So if I'm marking that, I'm going to look at your final answer. I want to see a 4 root 2. If it's there, I want something that justifies how you got it. Right? If this is just sitting there by itself, there's nothing else there, you could get 0. Right? Because especially if it says algebraically, right? It says determine, show some work. Method 2, same deal. So we rearranged area divided by length. So 10 root 48 over 5 root 6. So it's 10 root 8 root 6 over 5 root 6. So 2 root 8, which is equal to 4 root 2. Right? And that's just from there, right? So it's your choice as to the method you use for division, whatever you feel comfortable with, right? If you just want to say, hey, 48 divided by 6 is 8, so I'm just going to go with root 8. Or if you need to write it out so that you've got the same factor top and bottom, and you cancel, okay? You do what works for you. Determine, show some work. Will you see the word determine in the multiple choice / numerical response section? No, you can't, because you can't determine. Right? You cannot show work. Should you? Yes, show your work, please. On the numeric response multiple choice, please write in whatever you're doing to get an answer. Okay? Not that you don't get any credit for it, but if you get it wrong, we could sit down and look at it, right? Like tomorrow you can come in with a test, you'd say, this is what I did, what did I do wrong? If you haven't already figured that out over the weekend, right? But you can come in and say, what did I do wrong? This is what I did. We can look at it and see what the mistake was. If you don't write anything down, you know what? You'll never even get the wrong answer again. You'll try and work it out again, and this time you'll get the correct answer, and you'll be sitting there going, how did I get that? I don't even know how I got the wrong answer. Okay? So you want to know how you got the wrong answer. The area of a rectangle is 4 root 12 minus 10 root 6. If the width is 2 root 3, determine the length, and write you answer as an exact value. Okay, so same deal, right? What do we got? Area is length times width. This time we know the width, so what's the formula for length? Area divided by width. Okay, what's the area? Oh, wow. Okay, so 4 root 12 minus 10 root 6 over 2. So, okay, now how do we handle this?
On the top and
No, I wouldn't do that. Will 2 root 3 go into 4 root 12? Yeah, and will it go into 10 root 6? Yeah, so you look at 4 is divisible by 2 and 12 is divisible by 3. So this will divide evenly into this. So what method could we use? Well, we could write it like this. 4 root 12 over 2 root 3 minus 10 root 6 over 2 root 3. Right? Just like breaking a fraction up, right? So you think about if I'm adding two fractions, 1/2 plus 1/4, I'm then going to write it with a common denominator as 2/4 plus 1/4. And then I could write that as 2 plus 1 over 4. And what we're doing is just kind of backing that out. Like I end up with this 4 root 12 minus 10 root 6 over 2 root 3. I can split it up into two individual things, right? And I can divide these, right? I don't even know how you do it. So what's 4 root 12 divided by 2 root 3? 2 root 4. What's 10 root 6 divided by 2 root 3? 5 root 2. What's 2 root 4?
4.
So we get 4 minus 5 root 2. Okay, so that's one method, or method, that's method 1. Method 2, bless you, got the same thing. So we're going to start out the same. And we're going to say, okay, 4 and 10, what's the lowest common denominator? What goes into both 4 and 10? 2. What goes into both 6 and 12? Well, we could do 6, but we're going to say, hey, I could go 2 root 3. Now, 2 times what? So what I'm doing is dividing both of these by 2 root 3, really, right? Now, you can do that without doing the division. Just say 2 times what gives me 4? 2. 3 times what gives me 12? So I'm going to go 2 root 4. Minus 2 times what gives me 10? And 3 times what gives me 6? and that's over 2 root 3. And that's a common, and I'm left with 2 root 4 minus 5 root 2, which is 4 minus 5 root 2. Okay, so again, same idea as we're doing before, right? We're factoring out, but when you factor, we don't want necessarily, I don't want to write 2 root 6. Okay. I want to write it as, hey, let's take a 2 root 3 out because I'm looking to factor it so the top and bottom have a common factor which cancels, and then I just deal with what's left. Okay, questions? Comments? Concerns? No? Wow. Note, an expression that contains a radical in the denominator is not simplified. Simplify each of the following if possible. What's 12 divided by 3? What's root 24 divided by root 8? Root 3. Okay, cool, right? Now there's no denominator left, right? Just this divided into this evenly. Okay, and you get 4 root 3. What's 15 divided by 3? What's root 6 divided by root 8? What? What? Wait, we could do this. What's the root of, what's 6 over 8? It's reduced to 3 over 4. Okay, so hang on, how do we want to do this? Okay, let's do this. So that'll be 5 root 3 over root 4, right? Because I can split it back out. So I can pull them together. Really, you could just divide each of these by 2, right? So I'm going to get rid of, so this divides giving me a 3, and this divides giving me a 4. And I end up with this. And what's root 4? So we have 5 root 3 over 2. That's what that simplifies to, right? Could have got there a little bit simpler, right? We could just say that's 15. These are each divisible by 2, so that's root 3 over 3, root 4. Okay, which 5, so that gives me 5 root 3 over 2. Okay. Likely that, maybe comes out as a multiple choice question or something, or if it comes out as numeric response where we give you a root b over c and ask you for the values of a, b, and c. Okay. Which is numerical response then would be 532, right? But it's not really, it's 532. Root 8, root 50. So how do you want to do this one? We could do it this way, or we could do it this way. So do you want to write it as 8 over 50, or what goes into 8 and 50? What's the biggest number? 4 doesn't go into 50. What's the biggest number that goes into 8 and 50? They're both even, so we know 2 goes in, right? Is there a higher number than 2? So if 2 goes in, does 4 go in? No. Okay, so if 2 goes in, this becomes 4 root 4 over what? Root 25, which is 4 times 2 over 5, which is 8 over 5. Okay, now to me, that's the easier way to do it, right? Just what goes into 8 and 50 is 2. I'm just going to take a 2 out. Okay. You can also do it as 4 root 8 over 50, which becomes 4 root 4 over 25, which then splits out to this, and then this, and then this. Right? So you can go to here, or you can just go directly here, just divide both by 2, cancel it out. 5 root 10 over root 3. Does that simplify? Does not simplify. Because I can't, 10 and 3, nothing goes in, 3 doesn't go into 10. So the question becomes, well, what do we do with an expression like this if an expression that contains a radical in the denominator is not simplified? Then how do we handle, because it says simplify.
It can't be.
Okay, so right now it can't be done, but that means we need to come up with a way. Write each of the following by rationalizing the denominator. Oh, great, ran out of ink. By mine was there. Rationalize. So what we want to do is we want to turn, okay, this is an irrational number, right? A square root is irrational unless it has, square root 4 is 2. That's not irrational. But an irrational number is one that can't be expressed as a fraction. Any radical is irrational. Anything that isn't a perfect square, or if you're doing cube roots, isn't a perfect cube, whatever. So here's what we do. We see if we can reduce this, which we can't. So we multiply by root 3. Now, if I do this, what do I have to put up top? Otherwise, I'll change the value. What's root 3 divided by root 3? 1. What happens when I multiply a number by 1? You get the same value. Okay, so if root 3 over root 3 is 1, and I multiply by that, then I should get the same value, but the form may change, right? So what's 5 times root 10 times root 3? 5 root 30. What's root 3 times root 3? 3. Good. I hear she said it, right? 3.
Sorry.
No, that's good. I like that. Right? It's forceful. It's like 3. Right? Instead of saying like root 9. So if you can get to the point where you look at it and you say, hey, root 3 times root 3 is 3. Right? I don't need to go the root of, the root, different root, R-O-U-T-E. I do not need to go the root of root 3 times root 3 is root 9, and the root of 9 is 3. I just say root 3 times root 3 is 3. What's root 8 times root 8? 8. What's root 99 times root 99? 99. Good. Right? That's why you want to do it. If you've got a big number down there, root 10 times root 10 is 10. Don't go the root of 100 and then the root of 100 is. Right? Okay, does root 30 simplify? Nope. 4 doesn't going to do it. 9 doesn't going to do it. 16, no. That's it. Okay, so what have we got? 5 root 10. 5 root 10. I'm going to be lazy and just hit enter. Divided by root 3. This way I don't have to get out of the root sign. And 9.12. So what do you think 5 root 30, I'm going to be lazy again, divided by 3, so what should I get? 9.128. So, yeah, same, right? Good. Negative 4 root 20 over root 6. You can do this two ways. You could reduce 20 over 6 to 10 over 3, right? Say, hey, they're both divisible by 2. You could also just do this. Whatever's in the denominator, that's what I have to multiply it by. And whatever I multiply the denominator by, I need to multiply the numerator. So I get negative 4 root 120 over 6, right? Because root 6 times root 6 is 6. Okay, well, 2 goes into both of these guys, but root 120, can I simplify that? Well, 4 goes into it, right? So it'll be negative 4 times 2 root 30 over 6. And 2 goes into that 3 times. So I get negative 4 root 30 over 3. And root 30 doesn't simplify. I need to extend my radical sign a bit. Or you can recognize here, hey, 2 goes into 20 and 6, so I can write that as negative 4 root 10 over root 3, and then multiply by root 3 over root 3, and get negative 4 root 30 over 3, and not have to go through all of this. Okay. Either way, the correct answer is negative 4 root 30 over 3. You can get there both ways. This is just more work. So if you can simplify this, do so. Okay, and then you recognize I'm not allowed to have a radical in the denominator. What do? I multiply by that radical over itself. That gets rid of the radical, right? Root 3 times root 3. That's what's called rationalizing, changing a radical into a rational. right? Changing an irrational number, a radical, which is irrational, into a radical. Find the lengths of the rectangle shown below, given the area and the width as indicated. Write the answer as a simplified exact value. Okay. Did I miss a page? Oh, there's more. There's lots more. Wow. Yeah, sure. You can just not do it, and then when you get it on the test, you can just not do it as well. But that won't help you. So here's what we do. I don't need to multiply by 5 root 2. I only need to multiply by root 2. Because I only need to change root 2 into 2, right? By multiplying it by root 2. If I multiply the top and bottom by 5 root 2, I'm going to have an extra 5 in there I'm going to have to take out. So we don't multiply by the denominator, we multiply by the radical which is in the denominator. Just the radical. What's root 2? And the root 2, right? Treat that as if it's in brackets. So we got root 6 times root 2, which is? Root 12. We got minus root 3 times root 2 is? And on the bottom we get 5 times 2. Root 12 is 2 root 3 minus root 6, and 5 times 2 is? 10. Okay. So we have to turn the root 12 into 2 root 3. We have to leave the root 6 as root 6 because it doesn't simplify. We have to go 5 times 2 is 10. Can I do this? Is that it? So it's root 3 minus root 6 over 5? Can you do that? Which one are you going to think? Would he ask if you could do it if you could do it? Can you? No. Fix what you just tried to do. Can't do it. Why can't you do it? Because the root 6 would also need a 2 in front, right? It needs to be a common factor. The only thing you can cancel top and bottom is a common factor, and you can't factor a 2 out of the top expression. Right? If I could write that as 2 bracket root 3 minus root 6 over 10, then I could cancel. Easy way to determine cancellation is just say, okay, 2 goes into this and this. Does it go into this? No, there's no number here, so it doesn't go in, so that's it. I'm going to leave it. Okay, 6 is 3 times 2. 2 goes into this and 3 goes into that, but there's no, if this was even, I could take a 2 out. Again, same idea as a common factor, right? No common factors, can't do it. What do I multiply by? Root 6 over root 6. Okay, same deal, root 200. Now if you want, you could simplify that first. Okay, so do you want to do that? Should we do it? Because root 27, root 200. Why don't we do those first? What's the root of 200? 10 root 2, right? What goes into 200? 100. 100 into 200 is 2. I get 10 root 2. What perfect square goes into 27? 9. So root 27 is 3 root 3, right? It's root 9, root 3, root of 9 times 3, which is root 9, root 3, which is 3 root 3. Okay? If you need to, you can be off on scrap paper here going root 200 is root of 100 times 2 is root 100 root 2 is 10 root 2. And root 27 is root of 9 times 3 is root 9 root 3, which is 3 root 3. Okay? And now you've got this one. And then you go over root 6. And you say there's nothing that will cancel, but I now have this simplified. Right? Because ultimately I have to simplify. Whether I get root 1200 and take that down as, or I get this. So now we can multiply by root 6 over root 6. What's 10 root 2 times root 6? 10 root 12. What's 6 root 3 times root 6? 6 root. What's root 6 times root 6? I'll wait this time. Thank you. No, shout it out. Come on. No, won't go down any further. That's fine. Gotta extend the page. Now I gotta go up. Okay. What's root 12? 2 root 3. What's root 18? Need more space. 10 times 2 root 3 plus 6 times 3 root 2 over 6. Sorry, just over 6. So 20 root 3 plus 18 root 2 over 6. Is there a number that goes into 20, 18, and 6? What's the biggest number that goes into 20, 18, and 6? 2. 6 goes into 6 and 18, but doesn't go into 20. So we're going to divide everything by 2. 10 root 3 plus 9 root 2 over 3. And that's your final answer. Okay, a couple more, and then we'll go to the next page, and then... Okay, what do I multiply by? Why not 3 root 5? You only do the radical, right? You don't want to do the 3. All you do is introduce a factor of 3 and have to take it out in the end. Okay, what's 4 root 8 times root 5? 40, right? 8 times 5. Just multiplying what's under the radical sign. Minus root 15 over 3 times 5. Okay, root 40 is 2 root 10. Root 15 is root 15. Right? Root 15. It doesn't simplify, right? There's no perfect square that goes into 15. So, okay, we got 8 root 10. Is there a number that goes into 8, 15, and what number is in front here? 1. So no, right? That's a 1, so we're done. How do you know they're the same? And this is only if you finish early. You take this, you work them both out. That takes time. So this is, I'm done the test, and now I'm just going back and checking stuff over. Then you can do it. Okay, what can we do here? We can do a little bit of simplifying, right? Hey, 2 goes into 2 and 2 goes into 20. Now I got a root 10. Okay, what about root 8 and root 10? So this will be 2 root 4, and this will be root 5, right? Again, 2 goes into both. So if I do some canceling first, I'm going to save myself a lot of work. Okay? 2 root 4, what's root 4? 2. Okay, so I've got 2 times 2 times 6, right? 6 hasn't canceled with anything. Over the square root of? So it's 24 over root 15, but I can't leave it like that, right? So I multiply by root 15 over root 15. Any number that goes into both 24 and 15? 3. So 8 root 15 over 5. That's the final answer. Okay. It takes some practice, right? You could also just multiply this out. You could have got 12 root 16 over root 60. Right, so we got 12 root 16 over root 60, which is 12 times 4 over 4, sorry, that would be 2 root 15, which is 24 over root 15, which takes you to this point here, and then it all, okay? So you could simplify first. It wasn't really a huge deal if we didn't and just multiplied it out. Either way. Okay. Ready for the next page, or still copying it? Find the length. Is there more after this?
No,
Thank God. That's right. Okay, find the lengths of the rectangles given the area and the width. So, okay, area is length times width. Length is area divided by width. So it's going to be 10 root 3 divided by 2 root 6. Two goes into 10 5 times. Root 3 goes into root 6 how many times? So we get 5 over root 2, right? If we simplify, if you don't, you're going to be multiplying by root 6 over root 6. Still get the same answer. But now I multiply by root 2 over root 2, which gives me 5 root 2 over 2. Denominators rationalized. Because I simplified everything first, I don't have to do any simplification now. Okay, still got the formula. Length is area divided by width, which is 10 plus root 8 divided by root 5. Okay, what do I do now? Multiply top and bottom by root 5. Okay, remember brackets around here, it's a binomial. You get 10 root 5 plus root 40 over root 5. Sorry, over 5, right? Which is 10 root 5. What's root 40? 2 root 10 over 5. Done. Right? Because the 5 will not go into the 2. It goes into the 10, but you can't cancel. It has to go into all the numbers, right? It's got to go into 10, 2, and 5. And all it goes into is the 10, not the 2. You can verify this by seeing if this is equal to this, right? Which you would do only at the end of the test. Type in 10 plus root 8 over root 5 and type this in. So let's try it. Where's my calculator? So we've got 10 plus root 8. Turn that on. So I'm going to go 10 plus root 8, enter, divided by root 5. Enter, and I'm going to go bracket 10 root 5 minus 2 root 10, 2 root 10 bracket divided by 5. Whoops, I see how I need to go out. So I need to go back to here and delete everything. Okay, so I need to arrow out, then close the bracket. Right? So I'm saying work out the top, divide that by 5. In theory, I should get, okay, where did I mess up? Oh, it's plus 2 root 10. Second, enter, so let's change that. That should be plus. Okay, what should I get? 5.737. 04709. Yeah.